Hey, it's video 8-1. Today you're going to be viewing indications of a reaction, characteristics of equations, some additional equation symbols, and rules for balancing equations. Hey, so what are the indications of a reaction? How do you know a reaction took place? Okay, remember in reactions you have to have one or more substances change into different substances. Okay, it has to be a chemical change. Now, equations represent the identities and also relative amounts of the reactants and products. Okay, tells you how much of A will react with B and how much of C and D products will be produced. Okay, instead of writing out words, we use symbols, which represent our elements, and formulas, which represent compounds. Okay, now, how do we know that a reaction took place? Okay, well, a couple different things could take place. Not all of them have to take place. Well, you could have evolution of heat and or light. Okay, heat could be released all at once, in which case you end up with an explosion. That's the difference between an explosion and heat. How fast you release it. If it gets released super fast, it causes gases and things to expand. You get an explosion. Okay. Could be a production of a gas. You see bubbles, okay, where you did not start with a gas. Formation of a precipitate. Okay, now what's a precipitate? It's a solid that forms and separates from solution. In other words, the solid was not present when you started, but when you're done, you end up with a solid floating around in a bunch of liquid usually. Okay, or you can see a color change. Okay, be careful with this though, because you can see color changes take place and not have a chemical reaction. Okay, now, characteristics of an equation. Okay, it has to represent the known facts. It actually has to actually work. Just because you can say, oh, A and B plus C and D would produce, let's say, like A, C, and B and D. Okay, if the reaction did not work, even though you can say, oh yeah, well, everything works out, all the elements are there, if it doesn't work, then it's not a valid chemical equation. Okay? The formulas have to be written correctly. So going back to previous chapters, make sure that you can write your formulas correctly. Okay? And all the elements must be conserved. Law of conservation of mass. Okay? If you start with so many atoms or so many grams of A on the left side, you have to have the exact same element and the exact same amount on the right side when you're done. Okay. Now, what happens if we started out with like A2 and we ended up with A3? Well, we can put numbers in front to balance out the equation. Okay. These are our coefficients. Okay. And you cannot change the formula. So, if the formula is A2 and you were done and you said, oh, it's A3, you cannot just go and say, well, I'll change that to an A2. Okay, now, coefficients. They do represent relative amounts or ratios. How much of A reacts with how much of B, okay, and how much of C do you get, and how much of D do you get relative to each other. Okay, they can represent molecules or atoms if it's a pure element, or moles, okay, but it cannot represent grams. Okay, in other words, here's a reaction that's balanced. Okay, there's two of these hydrogens, and don't forget the proper form of our hydrogen is diatomic, so it's H2. Reacts with one oxygen, and you get 2 molecules of water. Okay, so this is basically saying, I can say 2 molecules of hydrogen reacts with 1 molecule. Okay, and if when you abbreviate things, remember MOLEC if you're going to abbreviate molecules. Okay, and I get 2 molecules of water. Okay, or we can say 2 moles of H2 and 1 mole of O2 will give me 2 moles of H2O. Okay, but you cannot say 2 grams of H2 reacts with 1 gram of O2 and gives me 2 grams of H2O. Okay, obviously that does not work, because if you took 2 grams and 1 gram, this has to be 3 grams. Okay, so that relationship does not work. Okay, you can use molecules, atoms, or moles. Okay, now some additional equation symbols you may see. Okay, in your book, table on page 246, table 8-2 will give you a bunch of things. Okay, the arrow, basically, this is the reaction arrow. You know this one. It means yields or produces. Okay. This double arrow basically means the reaction can go in both ways. So this is known as a reversible reaction. Okay. S, L, G, these are all phases, solid, liquid, and gas, that are written after the substance. Okay. AQ, you guys have seen this one before. This means aqueous. And aqueous does not mean it's an acid. Remember, aqueous means it is dissolved in water. That's all it means. Okay, so basically you have a solution. Okay. Now, this up arrow, this can only be used on the product side. Okay, and this basically means that a gas was produced. Okay, so let's say you ran a reaction, A plus B. Okay, neither of these are gases, and you produce C, and C was a gas phase, so you write the arrow after that. Okay, this basically means that the substance was a gas, and only on the product side, and only if you did not start with a gas. Okay, now the yields means, the arrow means the same as the yields. If you see a triangle written over it, this means that heat was added. Okay. If you see a chemical substance, a compound or an element written over the arrow, this is a catalyst. Okay. Now, why is it written there? You add a catalyst to the reaction. What is a catalyst? Catalyst will speed up a reaction, and it will participate in a reaction, but it does not get used up. Meaning, if you start with MnO2, you also end up with MnO2. Okay, it'll be unchanged. It did participate in the reaction. If you start out with 0.5 grams, you still end up with 0.5 grams of MnO2 when you're done. Okay, the down arrow. Again, this can be on the product side. Okay, this basically means that you formed a precipitate. Precipitate. Okay, and a precipitate is a solid. Okay, so that would basically be saying A plus B, you did not have solids there, maybe both of these were in solution. You produce C, and it fell out of solution. Okay, you can replace either of these with G, okay, or S if you want to also. Okay, now, rules for balancing your equations. Okay, all the elements and numbers of atoms must be conserved. Remember, when you balance the equation, we are using coefficients. Okay, and you cannot change the formula of all the substances that are written. The only time you could ever change the formula is if it was not correct. Okay, the coefficients can only go in front of, not inside of, or in between a molecule, okay, or a pure element. And the coefficients apply to all the elements in the molecule that the coefficient precedes. Okay. And once you're done, look at all the coefficients. If it's not in the lowest ratio, make sure you reduce it down to the lowest ratio. Once one of your substances in the reaction has no coefficient, that's the lowest, because that means it's at a ratio of 1. Okay. Don't leave coefficients as fractions. You can use fractions to balance it, but don't leave it like that. Okay, so a little practice. Okay, here's our reaction. Barium chloride with sulfuric acid, H2SO4, you get barium sulfate, and HCl, hydrochloric acid. Okay, now, how do you know if these things are balanced? Okay, eventually you'll get good at doing it, and you won't have to do it this way. But for practice, and until you get good at it, do it this way. Okay, first thing, draw out a little T-table. Okay. Then list all the elements that you see on the left side in the order that you see them. Okay, so we see barium, then chlorine, then hydrogen, sulfur, then oxygen. On the right side, even though they don't appear in the same order, list them in the exact same order. Okay, BaClHSO, same as on the side, BaClHSO. Okay, now under each element, list how many of them are on the left side. So barium, there's 1. Chlorine, you see the 2, so there's 2 there. Hydrogen is 2. Okay, sulfur, no subscript, there's 1. And oxygen, there's 4. Okay, and if you see bariums in 2 different places, don't list it twice. This is keeping track of the total. Okay, on the right side, you see 1 barium, 1 chlorine, okay, 1 hydrogen, 1 sulfur, and 4 oxygens. Okay, now, simple thing to do. How do you know if the reaction is balanced? The numbers should be exactly the same on the left side as you see on the right side. Okay, and they aren't, obviously. 1, 2, 2, 1, 4. On this side, we got 1, 1, 1, 1, 4. Okay, so looks like the right side, you can increase numbers, okay, but you can't really decrease them. So looks like on the right side, I need to change the chlorine and the Cl. Luckily, they're in the same spot. Okay, you remember, you cannot do that and that. You can't put subscripts there. You can only put numbers in front. So if I put a 2 in front, okay, it changes the H and the Cl. Get rid of the numbers, okay, and do not add to them. Just totally throw them away and then go back and recount how many H's, how many Cl's. So I got 2 H's, and the 2 also applies to the Cl, so I got 2 Cl's. Okay, 1, 2, 2, 1, 4, 1, 2, 2, 1, 4. The reaction is balanced. Your answer is not what you see on the bottom. This is your answer, the balanced equation. Okay, try another one. Okay, so again, make up our little chart. Okay, write down the elements that you see, Cu, Ag. Now, I'm going to do something a little different. Okay, remember, this is a polyatomic ion. This is made up of Ag plus and NO3 minus. So, the ions, as long as you see it on the left side and the right side, you can treat them like they're one atom. Okay, do not put charges in. Okay, now, again, repeat them on the right side, same thing. So, Cu, there's 1. Ag, there's 1. NO3, unless you do not have 3 of them. Okay, that's not how many you have. You can tell if you have more than 1 if there are parentheses. Since there's no parentheses, there's only 1 of them. Okay, on the right side, copper, there's 1. Silver, there's 1. Now you see the parentheses around the nitrate. Okay, and there's 2. So there's 2 there. Okay, so is it balanced? 1, 1, 1 on the left side. On the right side, 1, 1, 2. Not balanced. Okay, so I need 2 nitrates. Only thing I can do, again, is put numbers in front. So it has to go in front of the Ag and the NO3. Okay, now, that changes the NO3 to 2. That also changes the Ag to 2. Okay, cancel them out. Okay, now, come back on the right side. Put a 2 in front of Ag. And your number is 1, 2, 2, 1, 2, 2, and it's balanced. So this is your balance equation. Okay, Cu plus 2 AgNO3s will give you CuNO3 plus 2 Ags. Okay, try some practice here. You can copy these down. The answers will be given to you in the next video. And the review question. Which of these is not an indication of a chemical reaction taking place?